This year, on Halloween night, if you look up to the sky, you'll see a full moon. This full moon is special because this is an unusual month where two full moons occur. In this case, the second full moon is called a blue moon. Now, this name doesn't mean that the moon will actually be blue, but there are some cases where it can appear to be blue. Stay tuned while we explore the origin of the phrase "once in a blue moon," and along the way answer the questions, why is the sky blue, and why are sunsets red?
Hey there, Chris here from the physics department, and we're going to take a look at the origin of the expression "once in a blue moon." Now, there's some debate as to the etymology of the expression, but one of the plausible explanations is that it refers to a rare atmospheric occurrence that can cause the moon to appear bluish. And to understand how this arises, we need to talk a little bit about scattering, which is an interaction of light with matter that's a really key cause of color in the atmosphere. In fact, scattering occurs even when there isn't a blue moon. Imagine that you have these two observers here, and we've got the sun over here. And let's suppose that this person is sort of looking in the direction of the sun. And if there was no atmosphere, if this was happening on the moon, you would see light only if you looked in the direction of the sun. Of course, we can tell that the sun is up because if we were another observer looking over here, you'd be able to see the illuminated sky. Now the question is, how does this happen? The reason it happens is due to a process called Rayleigh Scatter, where you have atmospheric gases, little gas molecules around here, that intercept and absorb sunlight and then re-radiate it and give it off in all different directions. So these gas molecules, say over here, absorb some of the sunlight, pass it around and redistribute it out in different directions. And through this whole process, the light ends up being scattered. And so we end up with light that was originally coming in this direction, now being bounced around and coming from entirely different directions. And if we intercept some of that scattered light, we can see the sky. Now the question is, why is it that the sky appears blue? To answer that, we need to take a look at the nature of the scattering and the nature of the solar spectrum. So the first thing we want to think about is what the visible spectrum looks like. The visible spectrum is a plot of sort of the intensity of light as a function of wavelength. And so blue and violet light have short wavelengths, red light has long wavelengths. And if you build a mathematical equation to describe how the scattering works, what we find is that the scattering is stronger for sort of violet light and weaker for red light. If this was the case, you would expect to see the sky appear, sort of violet rather than blue. And the reason that it doesn't do that is that if you look at the sunlight and the distribution of light that is coming in from the sun, it tends to peak around the blue-green. So the fact that we have in the solar spectrum more bluey-green light, and the fact that the scattering tends to be more pronounced in these regions, means that the dominant color we see from the scattered light is blue. Now, as sunlight passes through the atmosphere, if you look directly at the solar beam, since we are taking blue light and more of the blue light out of the beam, what is left is this reddening effect. And so that's what gives you the red light at sunset, and also red moons at sunset. So let's take a look at a demonstration, first of all, of Rayleigh scattering to begin with, to demonstrate this blue sky effect and this red sun at sunset effect.
Hi everyone, I'm going to demonstrate the physics of scattering that we've been discussing using this fish tank here that's filled with water and the light source. The light source will act as the sun. So you can see that when the light source is on, it passes through the water and it shines this light on the screen. We see white light because this light contains all of the colors or the wavelengths of light, and they all pass through the tank and then show up on the screen. So now what I'm going to do is add a bit of milk into the tank. Just a little bit to start. And this milk will act as the atmosphere. So we should start to see that there's some scattering, and the higher energy light, the blue light at the end of the spectrum, will scatter more than the red and yellow light. So can we see? That tank will start to have a bit of a blue tinge. So we can see that the water in the tank is looking blue, and this is because the blue light is scattering the most, and this is what happens when we see the blue sky. Now we can also see that as the light passes through, since the orange, the yellow, the red colors are passing through, we're starting to see this orangey yellow color showing up on the screen, and that's what happens when we see the sunset. So let's try adding some more milk. And we can see that that blue color is increasing. I'll keep adding a bit more. Great, and then we can see that there's slightly orange light on the screen.
All right, so how do we get once in a blue moon? We've explained how you can get a red moon and how that's quite common, in fact, because the scattering there is due to this Rayleigh scattering, which is produced by the regular gases that we have present in our atmosphere. And again, that Rayleigh scattering dominates in the blue-violet end of the spectrum, leaving you with reddened light in the direct beam from the sun or from the moon. As it turns out, under rare conditions, when you have things like volcanic eruptions or soot from forest fires, you get a distribution of small dust or ash particles in the atmosphere. And the type of scattering that those particles produce dominates more along the red end of the spectrum. If you get exactly the right particle size, you can scatter red light as opposed to scattering blue light. And so what you end up with is a situation like once in a blue sun. And you can sort of see in this image from the pyramids here where you had very fine dust in the atmosphere, this blue sun effect. It's also said that this is the cause of blue Martian sunsets because of the dust aerosols that are present in the Martian atmosphere. So, under the right and rare atmospheric conditions, you'll have a blue moon.